a Maclaurin series. Actually, a Maclaurin series is a Taylor series. So they could have just called this Taylor series. Now, the question comes up about power series, okay, so we've kind of been playing around with them a little bit. A power series is a series that's a polynomial type function. We've looked in section 11.9. We found this nice formula that we could perform some algebraic manipulations with it. We could do derivatives and integrals, and we can get other power series from that formula that I called the foundation. You're not going to see it called the foundation in any textbook, but it's that big. And now, the question comes up, if I have a function, is there a formula to find a power series for a function that has a power series representation? Is there a formula for this? And the answer is yes, and it is the Taylor series. So here's a theorem that's in your book on page 760. And this is, they have theorem, they kind of continue it to the next box. Here's what I'm about, it's sideways, but I'm about to write this, all those things for you in the notes. So theorem, this is box 5 in your book. So if F has a power series representation, so sometimes they'll call that a power series expansion. At some number A, so they mean, when they say at some number A, they mean that it is centered at A. I'm going to put that, centered at A. So they say that is if f of x can be written as a power series, a series as in goes from 0 to infinity, of some coefficient c sub n, that is a lowercase c, mine looks like it's capital, c sub n x minus a to the n, and it converges for some interval x, absolute value of x minus a is less than r. If it has such an expansion, then the coefficients, that's the c sub n's, I'll write that in parentheses, c sub n's are given by the formula c sub n equals the nth derivative at a over n factorial. Now, the proof of this, they actually showed on the previous page in the book. And I'm not going to go through the proof with you, but you can look at it in the book, how they arrived at what the c sub n's would equal. So I would have this. So we get this, a formula for a power series expansion. F of x, some function, would equal the sum as n goes from 0 to infinity of the nth derivative at a over n factorial times x minus a to the nth power. This would, if I write out a few terms, it would look like this. Well, the 0th derivative, by the way, is just the function itself. The 0th derivative, when n is 0, we're just talking about f of a. What's 0 factorial? 1. So it'd be x minus a to the 0th power, and that's 1. When n is 0, this is just f of a. When n is 1, that's the first derivative at a over 1 factorial, which is 1, times x minus a to the first power. When n is 2, it's the second derivative at a over 2 factorial times x minus a squared. When n is 3, it's the third derivative at a over 3 factorial times x minus a to the third power. Now when the derivative becomes the fourth derivative, they'll start writing the number in parentheses raised. It is not an exponent. It indicates a derivative in that case when it's in the parentheses. So the fourth derivative, here I'm gonna have to write it on the next page, but I want to write plus the fourth derivative would be a 4 in the parentheses to indicate the derivative, 4 factorial x minus a to the fourth. So the next term, f, the fifth derivative of a over 5 factorial times x minus a to the fifth plus, I'll do dot, dot, dot right there. So it gives us a formula for finding a power series expansion. What does this become when a equals 0? What is this when a equals 0? It would be f of x It would be f of x is the sum as n goes from 0 to infinity, the nth derivative at 0 over n factorial times x minus 0 to the n. So I could simplify that. The sum as n goes from 0 to infinity, the nth derivative at 0 over n factorial times x to the n. There, when a is 0, it's going to look like that. Let's write out a few terms. So it would be f at 0 plus f prime at 0 over 1 factorial times x to the first plus f double prime at 0 over 2 factorial times x squared plus f triple prime at 0 over 3 factorial times x to the third plus the fourth derivative at 0 over 4 factorial times x to the fourth. So when a equals 0, it'll be that. Now when a is 0, that's what they call Maclaurin series. So Maclaurin series is just a Taylor series, but a equals 0. So I'm going to write that. When a equals 0, we have, it's a Taylor series. A Taylor series centered at 0, and we call this a Maclaurin series. And it's kind of like saying a square is a rectangle. Yeah, it's a more specialized form. On a test I gave, must have been last year, I worded the question something like, find the Maclaurin series, whatever, whatever, and one student really struggled with answering the question because she said, you didn't tell us what A is. But if I've said it's a Maclaurin series, A is what? A is 0.